Here we go again. So basically, this is so far what we showed up. Oh, there's also a real-time clock. Possibly you noticed it, there was a crystal, 32 standard kilohertz. Of course, the board grabs date and time from the internet at boot, so basically it's not needed at all. Anyway, there are a couple of nice demo functions which are not shown actually at boot. Actually, for example, we got F8, in which you can choose if you want to boot or not. Just in case. And well, so we skipped the auto exec. There's even a button on the board, and it lets you recover, so to say, which means if you have any kind of strange setting, it will stop you in there. The 3D, 3-dimensional color cube is a nice color demo. Sorry for the music. I mean, the music is nice, but and basically this is an old one. It is showing how slow actually. Unfortunately, it is the video interface. Basically, every frame is made up of should be 25,000, 160 by 160 pixels, and it takes kind of a minute and more, which means basically that every access to the video board is in the range of 10 microseconds. Okay, it's not important anyway at the moment. So we will let it finish, or maybe not. We can go hard reset, which is nice. And well, okay, no need for hard reset. We are done. Reboot anyway. Well, there's not much more to say. I mean, the board is very nice, of course. There's another hidden function. Sorry, wrong one. They are hidden for a reason, actually. And it will show up all of the ASCII characters. At the moment we have 3-4 available fonts in the video card, and well, of course the auto exec goes over, but it's not a problem, of course. And we got all of this stuff, and sorry, I forgot how to write on a keyboard. Well, so well, and this is it. Not much more to say. We can copy file, we can rename files. Okay, we have basically all of the stuff from old DOS. Yeah, it is nice in a way. Of course, all of this stuff has a web interface, which has been shown up already here and there. We have two different addresses. I'll try to show you it on the PC. It's not gonna be easy, just because focusing has been changed, but I will try to do my best. Say something like this, okay? So basically, this is a basic main page showing up a few things like, of course, version status, which has been used for debugging reasons. Oh, we also have an extra memory. At the moment, the main CPU has a 2 MB ROM and half a mega RAM, which is what is shown in here, considering that something is being used, something will not pop up in here and everywhere. And it's all available to BASIC, of course. And then you can have an extra static RAM, possibly 2 MB or even 4 MB, which is not installed in this version, in this board, but okay. Then we can go configuration, we can change something here and there, and then we can show directory. This is basically the same stuff that I made up for my Joshua long ago. There's something I want to show you, how easy it is to use, of course, UDP protocols on the network, in BASIC. Then we have actually another interface which is based upon the old microchip stuff. It looks nicer, more professional, could be, just because actually it comes from a more sophisticated, this is our wonderful, proud, still online 25 years later, homepage with a lot of nice stuff going on. Well, and anyway, this page is more sophisticated. It has more stuff going on, like variables which can be change it on the fly. So yeah, dynamic variable substitution, so they say. Form processing, where I already made it as well. We have real-time Java Ajax variables as well. Then we can go to the directory anyway, and yeah, something like this. Configuration page in here is more complicated. It also has a password. Well, okay, nothing special going on anyway. And yeah, you can do all of this stuff in here. If I am able to launch Wireshark, sorry for James Lester, which is in there. I love how the Star Trek things and not just them keep popping out. Anyway, yeah, this is Joshua for the record. You can see it. It's gonna be nice. It's always been nice actually. And okay, Wireshark will take a little time to pop up. Okay, it's coming now. I'm gonna start it and possibly block it on my address, which is 108. So now it is accepting protocols, frames, datagram, so to say, from my board. And okay, I can try pinging. Actually, it should work all the same. Yeah, it did, of course. So here are the ping requests. This is it. Sorry, I didn't make up the focus for the lens, but yeah. Okay, you already know this screen anyway. If I launch something which was called, if I'm not wrong, netu.bus, this is very easy, just like opening a file, a special file, sending data, and closing the file. So I will just run it. It's sending datagram, and on the PC we can find those datagram just like in here. The first one is actually sent by the way the framework was developed, not by me but by Microchip for the Wi-Fi module, has this need of sending a first datagram in order to set up the send-to function for those who know user data protocol API and yeah, programming interface anyway. So basically, yeah, we got an extra datagram at the beginning, and then we got the file that we sent with the usual payload, so to say. Okay, forget about it, it's not important anyway. And so, well, here we are. So, well, okay, basically that's all. Let me think for a minute if there's something that I forgot. Alright, nothing special, just to show you some commands, some graphic commands, something quite easy for everybody who's been programming basic language or actually whatever kind of language. And yeah, that's it. We got command for reading a mouse position, which will be used in the future. Yeah, we can use all of 16 million colors, of course. The VGA board is capable of 8-bit, which means 256 colors. I will show you it soon. It was stretching the peak to the limits, actually. I mean, as for generating the signaling properly at that speed, but possibly should be able to reach 800 by 600 VGA with 8-bit depth. Yeah. For sure it's been working at 640 and 480 basic VGA. Or this display actually is 480 by 320, 16 bits, which means yeah, 65,000 colors. Actually internally it is 18 bits, so 260,000. Well, we are not using it at the moment. And well, and in basic you can use a palette with 16 standard colors, just like in the old Commodore, or the full RGB values. You just have to set set color with the negative value. Now I'm just going randomly and something will happen. For example, it doesn't like it. Okay, doesn't matter anyway. So there are so many things that have not been tested, of course, especially because this whole thing is like a game in a way. How would you say? It's more like uh, a nice project, a nice testing even for myself, because having four CPUs talking together is something that I basically never did, especially on the same board. Which means making a whole board which features all these CPUs talking together. It wasn't easy. It wasn't easy actually, mostly because of this parallel port that the microchip picks have on board on chip is not actually so good as expected. So basically that's why now the speed is not so good. Actually it's quite awful, quite slow, and even a serial bus would have been better possibly. At the moment the bus is 8-bit wide, and then we have a 6-bit of function, which means the idea is like you send out a function on the bus, then you address the proper chip out of the tree, and then you can send some command, a stream of command. The point is that in order to make up for all these things, and also to, how would you say, adjust for these glitches, these things which were not clear. This is the first version, of course, of this board. We spend a lot of time just twiddling with bits back and forth, and it should have been better than this. But anyway, the display, for example, is driven completely in DMA access. So basically, what the PIC does is to create an image in memory, either 8-bit or 16-bit color image, which is then shown up on the VGA output, the composite output, just in case, just black and white in that case, and or on this display, which is actually completely continuously updated. It should be around 5 times a second. You can see it's not so fast actually, but it's good enough anyway. Or when we use a smaller display, for example, it was much faster. Say in this case, of course, it's gonna be quite faster. Again, this is a compromise between a lot of things. The display is driven in serial mode, and of course, this wastes like 8 times the possible speed, and it could have been a parallel display, but then we would have not had enough space on the board first, and then yeah, not even how would you say, no, possibly capability from the PIC would be available. The point is that yes, you could not have on the same chip VGA, LCD, and even a touch screen. It's possible we got a X and Y for the touch screen, and then composite with the basic digital to analog converter. So well, that's what I said. There are so many things in here, and actually they are all working fine. And so well, I'm pretty happy with it. You can hear we even have the sounds for when USB is connected, and yeah, it's very nice. This is the programming connector, which was planned to be using pogo pins here and there, and in this case I'm not yet using pogo pins, but it's okay. What else? 4 errors in this big and crowded PCB, so I'm quite proud of it. Yeah, just a few errors. This one actually is due to bug, a mistake in the datasheet, so actually it's not my fault. And the other 3 are actually something that turned out to be not working as expected, yeah. Or just issues with Eagle software making up the PCB. Anyway, no, everything is working fine, pretty happy, pretty proud about it, and well, next step is gonna be hard disk, just because I wanted to do that for many years now, and well, just to see some files on the hard disk. Of course, it is just FAT file location table 32, that's okay. And then, well, yes, that's all. 15 minutes. Bye bye. Have fun. Reboot.